Greetings, this is Jeff Johnson, creator of WeatherMaker. In this tutorial we'll be going over everything about the new volumetric clouds in WeatherMaker 5. This tutorial will be a little bit longer than other tutorials, so feel free to take a break. I'm going to be going over literally everything, so it might take 30 minutes or so. But let's dive right in and let's get started. I'm going to go ahead and click play in the demo scene here. On WeatherMaker Prefab Full Screen Effects Clouds, that's where the clouds have been living for a while, and they still are in the same place, and we have some new properties and new things to work with. First thing you should know is the clouds use a weather map. Now this is inspired by Horizon Zero Dawn and other new projects that have been using volumetric clouds, and in the weather map I'm going to go ahead and show this image. Let's pop that in. Okay, now let's show some clouds. So the weather map showing up, you can see we've got a red texture for cloud coverage and a blue texture for cloud type. The cloud coverage is mapped to the red channel, the cloud type to blue, green, and alpha, currently unused. So right now I'm using the medium heavy scattered cloud profile, which is very scattered, as you can see, very dotted. But if we use a different cloud profile, you can see we're zooming in a little bit. The clouds are a little more defined. Now, important thing to note with this weather map, your camera is right in the center here, and about 90% of the sky is probably in the inner 25% of the texture. So just keep that in mind as you're using the weather map. If your artists are going to design a weather map, that's generally the good rule, is that this kind of inner part is most of the sky. Okay, so let's go back to the clouds, and I'll go over these properties. We have the new temporal reprojection material. That's covered in the temporal reprojection video, so go ahead and watch that if you're curious about what that is. But basically, temporal reprojection can spread the rendering of these clouds over multiple frames. I think I'm using a 4x4 grid right now, and so it takes 16 frames to go through the entire clouds, but they're blurred smartly with a Gaussian blur and a temporal reprojection blur, so it hides pretty much all the artifacts you would see with temporal reprojection, but allows much better performance. These clouds they look nice, they're great, but they use a noise texture, a couple of noise textures, and marching through those and a shader for every pixel can get expensive, so temporal reprojection really helps out quite a lot, and I would suggest leaving that on. Okay, so the weather map has a couple of properties. We have the material, so I suggest you leave that alone, but we also have a mask override and a seed regeneration. So let me show you the seed regeneration first, then I'll show you the mask. So the seed regeneration basically changes the clouds every time they come enabled. So I'm going to deactivate clouds, re-enable, and you'll notice the sky looks different. Deactivate, re-enable, sky is different, sky is different. So let's uncheck that now. Sky's the same. So it depends on your use case. If you are deactivating and reactivating the clouds and you don't want them to magically change like that, turn off the seed regenerator. But if you want unique skies every time the clouds get activated, just leave that on, and every time you reactivate your clouds, you'll get a new sky. Okay, the weather map mask override. Let's show you what that does. I think I have a mask texture right here. So now we've masked out all of this section of the sky, and we only have this section of the sky. I'm going to go ahead and turn the mask. I'm going to turn that mask off for now until I show you how to animate the mask. Like if you wanted a storm to roll in from nothing, you can do that, but I'm going to show you that as we go through the profile. Alright, so the cloud profile. We have auto clone profile on change set to true, which means anytime you drag a profile in or the WeatherMaker engine changes the profile, it will be cloned. This is pretty important to prevent changes to the cloud profile. However, you may want to edit your cloud profile at runtime, and if you want to do that, I suggest turning this off, duplicating your profile, and then dragging it in, editing it, and then click stop once you're done editing. That will let you change things at runtimes and see them as you change properties. But for the most part, I suggest leaving that turned on, because otherwise you may accidentally mess up your cloud profile. And these profiles are pretty big and complicated, so I don't want to have anyone mess up their cloud profiles on accident. So anyway, if you do want to edit it, uncheck that and drag in a profile, and then you can go tweak it. So let's go into the cloud profile. We have our standard flat 4 layers here. We have our new cloud volumetric layer 1. Perhaps in the future there will be more volumetric layers, but this effect's pretty expensive, so I'm just sticking with 1 right now. These lighting parameters are very similar to what you've seen before. However, we have some additional properties. The cloud volumetric shadow is new. What this basically does is, if you're using the volumetric clouds and you drop this value, it will apply a global shadow everywhere. So let's zoom out a little bit. You can see we've got cloud shadows appearing, and this is done using Unity's screen space shadow masks. So in order to use cloud shadows, you have to support screen space shadow masks. Otherwise you'll just get a global shadow like the clouds have done before. I can show you how this works a little bit. If we can get the sun visible, you'll notice there's no cloud shadow under me. So let's go ahead and drop the sun behind the cloud again. A little bit more. Now we've got a nice cloud shadow. We're in the shadow of this cloud here. So it's really nice to have bright here and then have the shadows appear. Before, Weathermaker was just having kind of a global shadow, which didn't look very good. Like, you would have the sun in plain sight and see a shadow, and that's not a very good rendering. So the new volumetric clouds actually cast screen space shadows, which is very nice, and I think you'll like that a lot. But you can turn this down if you want to apply a global shadow. If you notice on the ground there, as I turn that down, look at the very bottom of the screen, you'll see the shadow just merges into a complete shadow. There may be cases where you have a scattered sky, or other scenarios. Maybe you don't want screen space shadows. I don't know. I think there's a couple of profiles that I have built in. One is a rolling storm profile where I turned that shadow down to 0 because I didn't want the sun casting these having random holes in the shadows. So if you've got kind of a big stormy sky and you just don't want the sun to be able to cast any light, then turn that down to 0. But generally you can just leave it on. Alright, let's go into the weather map. The weather map is kind of the heart and soul of the volumetric cloud engine for Weathermaker. Has a lot of properties, so let's get started. One is a weather map render texture override. This basically lets you change the weather map. Right now it's procedurally generated, that's the default. But if you don't like that, you can specify your own texture. I've got this hurricane texture I use that has a hurricane eye wall. You can kind of see this eye wall all the way around, and like I mentioned before, I mean, this is like right on the edge of the sky here. So one thing to note, and you'll see this property come in handy, is there's a ray offset. So if you turn that down, now we're not offsetting the ray and the clouds come up a little bit more. And you may have noticed the moon poking through. That's because I have a horizon fade on. You can turn that down if you don't want it. Probably for a hurricane you wouldn't want that to be so high, but for most clouds having that on is kind of a nice effect. Okay, let's go back and turn off the render texture override. So keep in mind when you're doing the render texture override, again, the red channel is the coverage and the blue channel is the cloud type. As that blue channel approaches 1, your clouds get higher and more fluffy and puffy. This weather map render texture mask is a way to apply that mask to a profile, and let's go ahead and put the mask back on, and then I'll show you some mask properties. So there's a way to offset the mask here, so the mask can be moved if you wanted to have a rolling system. So right now there's no clouds over here. I mean, other than these cirrus clouds. Those aren't maskable, unfortunately. Maybe in the future they will be, but for now they're not maskable. Just the volumetric clouds are maskable. But if you wanted to have this system kind of roll through the sky, you could change the weather map mask velocity. And so I'm going to try changing this to negative 0.005. See if that moves it at all. You can kind of see it moving a little bit forward. Maybe raise that up a little higher. And I don't want you all to have to sit here forever to watch this. I think it's already rolled past pretty much my whole field of vision, so let's change this to a positive 2 and see if we can watch it roll back. Speed that up a little more. Oh, it's already moving. There we go. So now it's rolling away. And if we leave that on, you'll see the whole system kind of roll out of view completely. And then we'll put this back and we'll make it go really fast this time so you can see how the whole system kind of roll through. And probably you'll want to match this with your cloud velocity. Right now this velocity is in UV coordinates, but you'll need to figure out your cloud velocity and then set an appropriate mask velocity here. In the future I may try to make that more seamless, but I didn't want to force the mask velocity and the cloud velocity unless that's what you actually wanted. So right now I'm leaving that up to you to decide if you want your mask velocity to match your cloud velocity. Okay, the weather map scale, I would suggest leaving that as a default. It basically maps a world position to a weather map position, starting with the camera at the center. The cloud coverage velocity, let's show you how these work. So this is a way to have your clouds move through the sky, and this is the thing you would want to perhaps synchronize with your cloud mask, is figuring out a good cloud velocity and mask UV velocity. And this is of course X and Y, but really this Y is the Z. And so you can see now the clouds are really moving fast. I believe this is like in meters, so our clouds are moving like over 1 kilometer per second, which is not very realistic, but helps you see the animations in action. Okay, let's turn those back down. I think you can even animate through the Z-axis, which is kind of the seed. Nope, I disabled that. So right now the Z is ignored, but the noise function here is a 3D noise function, but I'm ignoring the Z right now because I think if you animate too far in that, things go haywire. So right now the coverage velocity and type velocity Z is ignored. Alright, let's get into the scaling of the weather map. So right now I've got a 12 to 16 range. A lot of WeatherMaker properties now use ranges, so you can see the slider here will show ranges. So if you slide this up, your clouds become more scattered. So you can see that noise here is really scattered now, and it looks okay, but not super great, so probably turn that back down. You can even rotate the clouds, so if you wanted to have a huge range of rotations, you could do that. So now the sky is rotating. Probably as I drag that, you could, yeah, there we go. So now you can see the clouds rotating. So that just adds another level of variance to the sky. My goal with WeatherMaker is to basically have a wide variety of skies so that you're not seeing the same clouds every time you look up in the sky. That's pretty lame. I've seen a lot of other assets do that. You turn on the clouds and you get the exact same clouds every time, which is frustrating. Doesn't look great. You can add to the cloud coverage. So right now I'm not adding anything, but if you add ones, you get full coverage, or you could just add a little bit. And then of course, again, as I slide this slider, you can see how that's influencing the cloud profile. You can even subtract away the clouds. So that's again another nice way if you want to add some additional level of variance. We can add a power to the cloud coverage, which will make kind of harder edges to the cloud. So let's maybe do a power of 4. So now it's chopped away a lot of the power, and you've got much harder edges, which looks okay, but it's kind of creating some walls on the cloud, and that may be the effect that you want. And if so, you can ratchet that up and then maybe apply additional coverage, and now you've got more hard edged clouds. Okay, undo all of that. So the cloud type velocity is a way to kind of have waves go through your system. So let's turn that up really high and I'll show you what that means. So watch these clouds in the sky. You can kind of see this cloud type texture rolling over the top of the clouds. It's a nice effect just to vary the cloud heights and the cloud puffiness. So the cloud type noise is moving a lot faster than the coverage, so that's why you're seeing these kind of rolling bumps. It's just so with the velocity low, you're not going to notice those kind of rolling through, but it's going to create a very wide variety of skies again. So if I'm looking up at this sky here, and even if the velocity was 0, the coverage velocity was 0, if I came back a minute later and looked back, the puffiness and the heights would be a little bit different. So it's just a way, again, to vary the sky, and this is a similar thing where you can have powers there, and you can also do the same level of adding. Let's see if I can break that apart a little bit. So now you can see the clouds get a lot higher as I raise that, and then they drop down as we reduce the cloud type. So basically a cloud type of 0 is this flat. Okay, so anyway, with a adder of -1, I've basically reduced these to stratus clouds, which are fairly flat. Not completely flat, but pretty flat. But you can ratchet that back up to get the nice puffy ones. Okay, and then again, these have the same power if you want to change how that cloud type applies to the edges. This isn't doing a whole lot because my cloud type adder is so high. But if I reduce that to 0, now you can see this power taking more effect. Of course, a power of 0 basically makes it 1, so that's why that's going up so high. Alrighty. Let's undo all of that. Great. Alright. So we've gotten through all of the main cloud profile properties. It's quite a lot to take in. So if you need a break, need to go play StarCraft or something, that's fine. Come back and we'll go over the cloud layer itself. Alright, so we're going to go through the cloud layer now. This has a nice gamut of properties. Boy, there's like 50 properties here, so lots of customization options, so let's dive right in. So let's take a look at this part of the sky here and go through the textures. So first off, we have a noise shape. This is the 3D noise texture that WeatherMaker marches through to create the cloud shapes. So this is where kind of the performance is bottlenecked a little bit, is you have to march through this giant texture. I believe it's 128 by 128 by 128. And then we have a detail texture that's a quarter of that, 64, 64, 64. And then we have this curl texture, which is basically a way to add some noise and turbulence to the clouds. Some of these properties, like the sample count, LOD, and directional light, are actually controlled from the performance profile. If you haven't watched the performance profile tutorial, I highly suggest you do that. But basically you can configure sample counts, level of detail, and so forth for the clouds. But let's show you what the level of detail does here, right here. So as you raise the level of detail, the clouds get a little bit blockier because it's using higher MIP levels in that 3D texture. But it gives you a lot better performance. So on low-end devices, I have already set up the profiles to raise the level of detail. They also reduce the directional light sample counts. So as that approaches 0, you don't get any cloud shadowing within itself, but that doesn't look super great, so we turn that. Probably 5 is probably the sweet spot. And then you also have the cloud sun shafts, so let's turn this to the different profile so you can see these sun shafts real fast. So watch as I move the clouds, you can see these kind of God rays shooting out. This property here controls the sample count, and then you can go to 0 if you don't want them at all. 16 to 24 is a good kind of range there. Okay, so and then there's also a way to turn off reflections in the water if you don't want those, but they perform pretty well because I downsample a lot. Alrighty, so the cloud noise scale, the X value controls this noise shape texture scale as it marches through. So as you lower this, the clouds become more blocky because it's not moving through that texture as fast, and as you raise it, it becomes more pixelated and fine detail. Of course, there's a sweet spot, and that's probably between 0.5 and 1 is what I've found. We've got this detail noise scale, and that's this detail texture, which is just a way to provide kind of some additional edging on the clouds. You can see that as I change the scale, the edges of the clouds become more or less poofy and detailed. Again, I've tried to find some pretty good defaults for those. The Z value is the scale into this curl texture, and again, as you change this, the curl details become more and more fine. Again, as you raise that, you probably want to leave that pretty close to the default. And then this scale W is how intense that curl motion is. So as I raise that, the curl motion becomes more intense. You can see this is making the clouds pretty dotted around the edges, which doesn't look super great. So again, play with that to see what you want, but I've tried to make pretty good defaults. The noise scaler adds heft to the clouds, so as you lower this, the clouds become more wispy, and as you raise that, they become more dense. Just as a side note, if you lower these, you will take more performance to render the clouds because the ray marcher will exit out once it's got a fully opaque pixel, and as you lower this noise scaler, it takes longer to find a pixel. This cloud height noise power is a way to add bulk to the bottom of the clouds, so let's go ahead and show you what that's doing. As I raise this, you'll see the bottom of the clouds change. It's really, I'm going to change that to a 1. Might have to change this manually. So now we've really bulked up basically the entire cloud structure, so there's not a whole lot of extra noise. It's basically a way to add kind of heft and structure to the bottom of the clouds while allowing the top to be poofy and wispy. So you can see right here about half this cloud is kind of bulked up and then the other half is not. If I change that to 16 now, basically almost the entire cloud is allowed to have the poofiness and stuff. So depending on the effect you want, you know, a value of 6 will give you some nice thick wispy bottoms and with some puffiness on top. You could even go down to 4 and it looks fairly decent, but I kind of like having the puffiness everywhere, so that's why I've set these a little bit higher, because I like these puffy effects. But if you don't like those, feel free to change these. Okay, the ray length is the maximum distance you're going to be marching through the sky. So as that increases, you will march longer distances, and as that lowers, you march less distances. I found a sweet spot to be about 10. Yeah, I'll show you a fly through in a little bit, and the fly through needs a little bit longer ray length because you're above the clouds and you have bigger distances. Optical distance, again, mostly just controls that horizon fade that I showed you earlier, and again a value of 10 is pretty nice there. This horizon fade again just tweaks how that works. The ray dithering, so if you see banding in your clouds, sometimes you'll see little bands here. So if I turn this ray dither all the way down, see if we can see any banding. I noticed some other assets on the store having banding, and I was like, well, I need to fix that, make sure these don't have that. So I added this property, but everything's looking pretty good. However, if you do see banding, you can raise this. Obviously, if you raise it all the way up, you get nasty looking clouds. But if you do see banding, you can raise this up a little bit and it will kind of randomize it out, and then with the blur kind of hide that artifact. Typically you would see banding with lower sample counts, so let's pretend I was in a profile with low sample counts. Now you're kind of seeing the banding come into play, and it's a great time to now consider raising this dithering a little bit. So now we've hidden kind of that banding, and now using basically a half sample count, you get some still decently looking clouds. So for a low-end device, this is not half bad, and then of course on a lower resolution screen this will mostly be blurred out. So keep an eye on your banding, and if you see it, you can raise the dither level. Alright, let's turn the sample count back up because I don't like lower quality clouds. Okay, we're getting there. Where did we leave off? So the ray offset is the next one, and that was the one that I showed you with that hurricane earlier. It basically brings the clouds down. So let's turn off the horizon fade. Now you can see we've got kind of like these tiny clouds on the horizon. They don't look super great. So the ray offset's a way to just hide kind of the really far away clouds that don't look as nice. Alright, so the min ray Y is a performance optimization. Now WeatherMaker already uses the depth buffer here, but in the event that you have some open areas or you have high mountains everywhere, you can raise this and it will not render clouds with a certain ray direction. Generally you probably leave that as is, except for the fly-through. You want to put that to -1 because obviously you'll be looking down through the clouds. Okay, let's take a look at this animation properties. So you can animate the shape and the detail position. So let's go ahead and animate these a little bit heavier. You can see a negative value actually makes it animate up, and a positive goes down, which is kind of funny, but that's just the way the noise seems to work. And then you can blow it different directions. So if you want to add a bunch of turbulence to your clouds, this is a great way to do it. You can also animate the detail the same way. And now you can see those animations basically only applying to the edges of the clouds. Alright, cloud colors. Let's take a look at this. This is basically a way to make your clouds different colors. Say I was on Venus, I could do something like that. It's kind of, I believe the most similar analogy is a diffuse color there. Your clouds can also emit colors, so this is totally independent of the sunlight. So even at night, your clouds are going to be red if you're emitting red. So we've also got this directional gradient. So as the sun hits the horizon, right in the center of this gradient, you start applying this tint color. And then let's change this to white. You can kind of see it changes the color a little bit. So this is probably more for your artist to have a look at and change how the sunrise and sunset looks. Alright, we're about halfway through. We're almost there. So these are all the lighting parameters. So the directional light intensity can be controlled with this slider. So that's general directional light intensity. You've got point spot multiplier, which is the lightning, and we'll show you some lightning in a second here. The light step multiplier is how far each ray march to the sun works, and that's basically how the clouds self-shadow themselves. Generally a value of 1 is probably what you want and looks the best. Light absorption controls how much the clouds absorb the sunlight, so as you raise this, more and more sunlight is absorbed. The Henye-Greenstein phase is kind of the silver lining effect, so let's look over here. You can see the edges are nice and bright and the inner parts are darker. You can control the forward scattering. Probably want to keep that as a positive value. You can control the back scattering, which is kind of when you're looking away from the clouds. And I've chosen pretty good defaults, so I would suggest you probably not mess with those. but you can increase the forward intensity and you can increase the backscattering intensity. Ambient light is a key feature for the clouds in determining their appearance. This ties directly to the day-night cycle. So my day-night cycle default is what I've matched all of these built-in profiles to, and I think it looks pretty good. So if you're wondering why your clouds look too bright or too washed out, check your ambient settings and see if your colors are close to what these are. If they're not, then you'll need to change your clouds to use different ambient levels. So we've got the ambient ground level, so that controls how much ground light affects. So obviously on an ambient 0, that's as if there was no light bouncing off the ground and no city lights or anything, which not super realistic, so you probably want to raise that a little bit. The sky, the ambient sky, uses these properties here. So we've got sky for dawn dusk, sky for day, and then sky for night. So these colors are brought in right here. So as I raise this, it will use that color more. And then if I'm at a sunset, you can kind of see how that brings in the sunset colors more. And then the night colors. Obviously, you probably want to leave this one fairly low. The cloud sky intensity uses the pixels of the sky. So right now I have a fairly blue sky. So as I raise the sky, you're going to just see the clouds get more blue and white. And then of course if it's nighttime, then this will have a little bit less effect or none at all. But this is a really nice one, especially at sunset, to really bring in the extra colors here. So as you can see, the sky is kind of this yellow red, and as you raise this, you can get more of that sunset kind of bleeding through. That's probably a little bit too much, but you kind of get the idea of what that's doing. The ambient ground height just controls how the ambient ground color goes up through the clouds. So as I lower this, that color is only going to apply to the bottom of the clouds, and then as I raise this, it's going to go up to the top of the clouds. I may need to raise this color a little bit so you can see that more in action. So now the ambient's more on the bottom of the clouds, and then as you raise up, it goes up to the top. And the sky is the same thing. As you bring this to 0, the sky only applies to the tops. And as you raise this, now the sky begins to apply to the whole cloud all the way to the bottom. Any value between 0 and 5 and 1 looks pretty good, depending on how dark you want the bottoms of the clouds to be, how you want to blend them with the sky. We've got cloud shapes for stratus, stratocumulus, and cumulus. Basically, in the weather map, there's this giant sphere around your scene, and you have a cloud a range of heights. I believe that was on the cloud profile itself. Yes, in the planet. So we have a 1,500 meter bottom and a 4,000 meter top, and a planet radius of 1.2 million meters. I think the Earth's radius is 6.321 million meters. I should probably also tell you there's this camera scale. So as you move around, you can see the clouds don't really move at all, and I'm moving pretty fast right now. Let's put my position back to the center so you can see how fast I'm moving. So I'm moving at like 50 meters a second, and the clouds really aren't moving at all. But if you go to this and change this to 1, now your clouds are going to move a little bit more as you move. So depending on how fast you want the clouds to move with the player, you can set that position scale. A value of 0.1 is great for most cases, but for fly-throughs you probably want to leave that at 1, and I'll show you that after I get through all these cloud properties. Okay, so we've got stratus, stratocumulus, and cumulus. Basically, as you're marching through this texture, depending on the height that you're at, you will get stratus, stratocumulus, or cumulus clouds. And these gradients determine where those clouds appear. So for example, you'll only get stratus clouds on the smallest part of that layer, and then the stratocumulus about halfway through, and then the full cumulus basically through the entire layer. Alright, so the noise min and max are useful for determining how well formed the clouds are. This is the minimum level and the max. So basically if you converge these to the same value, you're going to get clouds that are kind of messy because the noise is basically the same value every time. So generally you'll want to spread these out for more variety of clouds. There's definitely a sweet spot I found with this, and I've tried to pick that for most cases, but it's basically a way to make your clouds more structured or more kind of deformed. The powder multiplier, when you've got the sun out, I don't know if you've looked out on a cloudy day, but if you're looking away from the sun at clouds, you can kind of see more of these dark bumps. That's what the powder multiplier does, is it kind of brightens up the back sides of the clouds and kind of makes some of these dark edges more visible. The cloud bottom fade kind of hides the flatness of the clouds at the bottom. If I change that to 0, you'll kind of see a little bit of I would call that an artifact, but it doesn't look super great. We've got kind of this hard edge on the bottom here. And I noticed that, and I was like, there, we need to find a way to get rid of that. So this bottom fade is a nice way to just kind of transition away from that hard bottom edge. Alright, so the profile itself can also change the cloud cover, just like the weather map overrides on the full profile. So if you remember, on the cloud profile itself, there's all these coverage and type properties. Well, those also exist on the individual volumetric profile as well. So the profile can change the coverage. I've got this secondary cloud coverage, which is kind of this whirly noise texture. So as you raise that, it brings more and more of that whirly noise in. Just a way to add a little bit of extra volume to your clouds without having to change the base coverage. Cloud type, again, same thing. As you raise that, clouds get higher and more poofy. And then you can also apply kind of a global coverage from a wispy texture. And I'll show you that texture since it probably doesn't make a whole lot of sense. So on the weather map material, I've got this whirly noise for the coverage. That's the secondary coverage texture, and then this type texture is kind of this wispy texture. So there's the wispy texture, and there's the whirly texture. You can change those, of course, to whatever you want if you want to have a different secondary texture. So the flat layer, let's look at the density. So the density is yet another way to make the clouds more or less well formed. Generally, you'll want to leave that in the 0.9s or higher. Okay, so the flat layer mask is a way to determine whether these flat layers show up if volumetric clouds are turned on. So you'll notice these 4 flat layers. Layer 4 was a cirrus layer, and then actually layer 1 of this profile is a medium cloud layer, which is disabled. If I was to turn off volumetric clouds in my performance profile and then switch profiles, we would go back to flat clouds. Which is, for a really low-end device, that's probably your best bet. But I'll turn these volumetric clouds back on. But anyway, a volumetric cloud can determine whether it shows the flat layers or not. There's actually a profile that does show a flat layer. I'll show you that in a second. Okay, so these clouds draw light rays. This is basically a way to control the cloud God rays. So let's show you that. They work basically the same as the fog God rays. So if you've used the fog God rays, full screen sun shafts, this is basically the same thing. Now the sample count is controlled by the performance profile, so changing that will do nothing. But these other parameters should change things. So this controls how it spreads out. This controls brightness. This controls march distance per march. This controls how it decays from the center. And then you can tint them if you wanted red or something. And then the dithering I would suggest to leave alone. It's just a way to randomize the noise a little bit. Obviously a sample count of 16 is not covering every pixel, so I add some little dithering voodoo parameters to kind of randomize things a little bit. As you raise that, you'll notice kind of some more, you'll see some dancing dots, so that means you have too much dithering. Anyway, okay, let's show you a couple of cloud profiles that I made. One is the rolling storm profile. So this profile actually uses a flat layer mask. This gray stuff up here is actually layer 1. And then you have the volumetric layer and then even cirrus clouds, which aren't actually showing up because they're behind this gray layer, but that's fine. So you can see this nice rolling storm here. I'm going to go ahead and turn it to kind of dawn and dusk. So it looks pretty cool, pretty creepy. Throw some rain and wind in there. You've got yourself kind of a nice storm. But anyway, this obviously looks a lot different than the other profiles, and that's because I've changed the ambient settings, the cloud types. They're all kind of customized for this kind of epic storm look and feel. Alright, now I promised you I would do a fly through, so let's go to demo scene fly through. So right now our player is actually at 5,500 meters. If I go ahead and click play, I've already set up WeatherMaker to use the fly through profile. So on the clouds I've already set it up to use fly through. So you'll notice we've got our nice poofy clouds. You can see the cloud shadows underneath. And there's our sun, so the sun is casting shadows that way. Shadows move nicely as the sun moves. Now you can actually fly through the clouds. I think my player will move 500 meters a second, which is basically the speed of a fighter jet, so you can actually fly through the clouds. There's my tiny little platform there. I'm going to fly through all the way down to the platform. Almost there. Here we are. And then there's our cloud system. So you'll probably want to watch me fly up through the clouds. Let's go ahead and do that. We'll fly right through this poofy section here. Now you can't go too super high. I mean, if you're like at 10 or 20,000 meters, then you start to see artifacts on the horizon. But for a flight simulator, this is probably about as high as you would want to go. And then you can fly right down, back down through the clouds again. Now there's a couple of gotchas with fly-throughs. I mentioned earlier that ray offset, so let's take a look at the fly-through profile and see what's different. So the ray offset is obviously 0, and the min is -1. So let's put the player back up above the clouds, and you'll see why those properties can't be used for fly-throughs. If you change the min ray Y, well, as you're looking down through the clouds, you get this problem. So if you see that in a fly-through, check the min ray property, min ray Y property. The ray offset also doesn't look very good because it brings kind of the whole cloud volume down, which for a fly-through, again, not super great looking. And the horizon fade is a little bit less on this as well, because as you can see, the horizon fade doesn't look so good on a fly-through, but I've got a little bit of horizon fade. Okay, so that's the fly-through. One other thing of note is the main camera plane is fairly high, 67,000. You'll need to match that up with your world, so just tweak this until the clouds line up. If it was too small, you would see this kind of a scenario where the ground kind of disappears and there's clouds floating in the air. If it's too big, then the ground kind of extends too far past to the clouds, and that doesn't look good either. So it's basically trial and error to basically try and line these up perfectly with each other. Alright, let's make sure I didn't miss any properties on these clouds. It looks like I didn't. That's quite a lot of information. If you made it this far, wow, congratulations. I look forward to hearing your questions and feedback on the volumetric clouds. This is something I've been working on for 3 months straight, full-time, 8 or 10 hours a day, so I hope you enjoy them a lot. But there could be bugs or problems, certainly, and if there are, please send me an email, support@digitalruby.com, and I'll do my best to help. Thanks, and send me your projects. I'd love to see what you're working on with this, and have a wonderful day.